Hey everyone.
Hello, hello.
How's it going?
Good. Missed you all.
Yeah, it's been a minute.
Yeah. Hope the break was good for everyone. Cool. Well, I think we should go ahead and get started.
Hi, Zach. This Annie, my camera's got a flip switch. I forgot where it's at.
No problem.
I'll get it. Thanks.
Good to hear from you. Cool. So this is the last module. There's the capstone after this, but that's not a traditional module. So there's you're not learning as much new stuff in the capstone. It's much more applying, though obviously you learn a ton of stuff while you're applying. But no more official curriculum for the capstone. And so yeah, this is the final module. And so that's a big deal. Congratulations for getting here. I know it's been a long time since we embarked on this journey. Yeah. So the last piece to learn is so we're really into the back end part for this module. So what we're doing in this module is officially what most people would consider a core part of backend programming when it comes to web applications. So when you're building a web application, which is like, most websites you interact with through the web browser, those are web apps. We're learning about the backend piece of that. Now, the backend that we're going to be learning and all the stuff we're learning also would be the same thing you would need to create a backend for like a native app. So like we're going to be learning how to build a backend, which is a server and a database. And a native app, for example, like an iOS app or an Android app, could also talk with and use that same backend. So it's not exclusively for web apps what we're going to be learning. It's so yeah. So I want to do a little just high level whiteboarding stuff, just so we can orient around kind of how all this stuff flows and works. I think I've done this a little bit, but I kind of want to go in a little more depth on the back end side this time. Did you have a question? You're muted, by the way.
No, I'm cool. I was just, it is a teeny tiny little button on my new computer to activate the camera. Let me save you guys the trouble.
Okay.
Let's see. Oh.
I will trust you all and give you edit permission on this whiteboard. Okay. Can you all see this?
Yes.
Yeah.
Yes.
Great. Okay. Yeah, feel free to pretty up whatever I do. So we have been doing, I want this to have a background. Yes. Okay. We have been doing almost everything we've been learning in the web browser, and that's often referred to as the client. You'll hear that. We did do some things on our computer in the third module. We did some stuff with Node. And then obviously you were using Node a little bit when you were doing React to like kick off the React server that then like lets you see your app in the browser. But most of the work we've been doing has been in the web browser. So that's our client. Whenever you're doing an app, a web app that is more than just displaying content, like you're like logging into it, or you're like submitting an order, or you're submitting a blog post, or you're querying for data that's unique to you. That is always interacting with some backend server. So and how do we talk with a backend server? Does anybody know like what the protocol is that we use to talk with the backend server?
HTTPS.
Yes, correct. HTTPS. Yes.
Bam.
So we talk with a server in order to send information, get information, delete information. So for any kind of fancy web app, it's usually interacting quite a bit with the server. Now the server can do, I mean, anything. It depends on the needs of your business and what your application does. So to give like a very, very advanced example, if you think about like using Uber, you know, and like requesting a taxi, you're using a native app. Though I'm assuming you can probably order Uber through a web app as well, but you're typically using like the native app, and you know, you're opening that up, and that's getting your current location and kind of showing that on a map. But then it's immediately making a request to well, not immediately. So you're usually then like saying, hey, I want to get an Uber, like an Uber X or whatever. And at that point, it's sending a request to the Uber servers saying, here's where this person is, here's who they are, and where, and they want to ride right now. And so then that server is then going to kick off all the processes needed to figure out who around you is available, right? So it's going to say, here's their location, and then it has in its database where all the current people that are like logged in and accepting rides are. So it's going to like search for who's near this person, and then it's going to say, okay, well, like we should ping these people to see if they'll accept this ride. So then it's sending and then actually that's for a server to send something to a client is actually kind of a fancy thing, typically called a WebSocket. That's more of like an advanced case, but it's like basically pushing to all the different people's phones that are drivers, like, hey, do you want to accept this ride? They would hit, you know, yes or no. Whoever hits yes then sends, you know, back a request to the server saying, hey, they'll accept this ride. And then the server then pushes to us, hey, here's your driver, they're going to accept your ride and they're coming. And then it like keeps telling you where they are and keeps updating you until they finally get there. And so just within that, like, you know, wonderful interaction that we enjoy of getting a ride with Uber, there's like a lot of complicated things happening. And your client, like your web browser or your native phone, isn't doing any of the complicated things. It's just simply displaying information. It's simply like sending information and receiving information. It's not doing any of the like business logic or any of the crunching of like significant like advanced types of things. It's simply like a dummy thing that's displaying stuff typically. And the server is the thing that's like orchestrating everything and doing all the like fancy business logic to do that thing. And in the case of Uber getting you that ride. And if you think about it, so that was just one piece of it, but there's also, you know, after you finish the ride, the server is going to orchestrate other things like sending emails to you, or maybe sending text messages to you, and all these sort of peripheral things that happen typically whenever you're interacting with something. So the server is going to interact with you through the client, but then the server itself will then typically talk to, change the shape. Well, that's unfortunate. They don't have the typical database shape. So we'll do, this feels like a database. So the server is going to be talking to a database, which is just something that stores all the information. So it's persisting information for a long period of time. It's housing all the data. So like whenever you talk with the server, it's like it's probably looking up your information in the database to make sure that you're a user that they know about. They're then querying for, like, probably the database is constantly being updated with locations of drivers and things like that. So the server's querying the database to get that. So there's just, a ton of information is going to be stored in a database. Eventually when you finish your ride, there's going to be a record in Uber's database of that ride. That's just going to be there forever. And then whenever you, like go to your phone and want to see your ride history, it's querying, the server is querying the database saying, hey, for this ID, this person, give me all the rides they've done in the past 30 days so I can show that to them. So like all kinds of information is persisted in the database, and the server is, asking the database for that information and then passing it along to you. So that's one thing the server will interact with as a database. And then if you think about it, whenever you finish your ride, and you get an email that your ride is completed, the server is going to typically talk with some API. We used to have to like write all this stuff ourselves, but nowadays there's all these kind of companies that pop up. So if they need to send an email, they're going to use a service. Well, I don't know for sure what they use, but like they could use a service like SendGrid, for example, is a email provider. So they might, for emails, they might use SendGrid. For, let me get another one here. For text messages, they may use Twilio. And so these are all like companies that their focus is doing emails really well, or doing text messages really well. So you don't have to write all the code to do that. And they have an API that you can use to do it. And so the server will send an HTTP request to send an email. And that's how they'll interact with that service. So and same thing with Twilio. And so if you look up Twilio, not the actual, so I use Twilio to send text messages, but I want the marketing site.
So SendGrid is a company underneath Twilio.
I think it is. Yeah, I think they got bought.
Nice.
Yeah.
Got that whole ecosphere.
Yeah. So yeah, you can see, here's, this company, and it's, they're not really saying much about text messages like right away, are they? Products. Oh, they do a lot of stuff. Okay. So I mainly think of them as messaging. So you can see within their products, messaging, send and receive text and media messages. Looks like they do WhatsApp too. So this is the main thing I know them for. And then the email section, you can see they mentioned SendGrid here for that. So yeah, you can use Twilio to send text messages. And then these types of companies that are mainly focused on selling to developers, selling to other developers that will use their service. There's typically like a developers section here with all the documentation for how to integrate with them. And so we can like go to the documentation for sending text messages. And then you'll see they work with all kinds of different languages. It's not just JavaScript that they work with. And so you can see they've got this Node.js quick start, which is, since that's what you're writing in, that's what you would use. And then they start giving you documentation for how to send text messages. So you can see here's some sample code of it. And this shouldn't
Are you
be.
sharing your screen?
Oh,
are
I
you
don't
sharing the
see
whiteboard?
I'm so sorry. I assume this will save the whiteboard. Let's hope. Okay, sorry. So I'm on the Twilio developer docs here. And you can see I clicked on the Node.js quick start. They have other languages like Java and PHP and .NET, and Python. But here's their kind of first snippet to kind of show you what that, how to use their service. So you install, they provide a node package called Twilio. So you install with npm Twilio, and then you import that package. And the way, like, because you're paying for it and it's like, not just free, and like they have to know who you are to allow you to kind of send messages and bill you appropriately and everything, you will get typically a like secret token that only you know about, like through the, whenever you sign up, they'll give you, here, use this token whenever you're using the API. And so this process.env.twilio auth token is a way that you can pull the token from your environment and not have it sort of stored in your code, because it's not a very, like, putting sensitive information in code is like not a good practice. You usually want to have it be sort of like limited access to it, and only the person like deploying it would know it and put it in the environment, basically. So anyways, there's like a secret token that you'll use to talk with the client. And then so this pulls in the Twilio client, and then you simply call .messages.create and then put the body, which is like the text message, and then who's it from, which is a number that you would have made in Twilio. There's like all this regulation around getting a phone number, and then who you want to send it to, and that's it. Like, that's it. And this is a promise, obviously, because like sending a text message like takes a second, but we do, create and then and then it would respond with information on whether that message was sent successfully, or if it's like an unknown number, or you were blocked for some reason. But yeah, like, all these companies are doing all these types of things to make, sending text messages easy or sending emails easy. And so but the server is the thing that's then going to integrate with that. So you don't ever integrate with Twilio in your browser. You always do it through the server. So let me go back to the whiteboard that I hope is still there. Yes. Okay. So the server is the thing that will integrate with whatever services make sense for whatever it is you're trying to build. Yeah, that's what we want to learn about in this module. Not necessarily the sending emails or sending text messages, but more focused on how do you write a server so that your client can interact with it and get the information it needs. So how do you write an API? So how do you expose different GET requests and POST requests and put requests and delete requests to basically manage different application data? And then, when you write that API, how do you then hook those API calls up to the database? So how do you then interact with a database? And databases are their own whole spectrum of something to learn. There's a ton of different kinds of databases, that have different strengths and weaknesses. And so that's a whole thing to learn. So we're mainly going to be focusing on how do you, how do you talk to a database and store information in the database, and kind of what different databases are out there. And then how do we write servers? So that's what we'll be focusing on in this module. And then we'll also, whenever we write our different routes for our server, we want to then hook them up and use them in the browser. So we'll still do some stuff in the browser, mainly in terms of just like integrating with the API that we write. So typically, if you're a full stack developer, you're writing both the server and the database code and the browser code, and you're hooking them all up and adding all the features you need for whatever you're trying to build. So, if we're trying to make a coffee company that sells beans online or something, right? You would need the front end that allows people to see your inventory and, submit an order. And then, you have your server that needs to charge them. So they're going to integrate with a billing provider like Stripe. I'm sure some of you have heard of Stripe. And, successfully charge their credit card. And then if that worked, then, create an order in your inventory system. So whoever's like working the warehouse sees that, they need to send something to somebody. And then kind of like update the data as that gets sent, and like sending emails to the customer saying, hey, we got your order, and then everything else involved in there. So if you were a full stack developer trying to make that company, you would write all the stuff to do all that. Okay, any questions or anything?
Are we gonna focus on? I guess not yet. I don't have questions.
Cool. Okay. Anybody else? Don't be shy. Okay. All right, so let's talk a little bit more about this piece here. So you guys have learned a bit about the different HTTP methods already. So does anybody remember the 4 main HTTP methods that we'll use?
Get, post, put. What's the
One more.
get, post, put?
How
Delete.
do you delete? Yeah, good. Yeah. So get and delete sound like what they are. One's to get information, one's to delete. And then post is to create information for the very first time. And put is to update existing information. Good. Okay. So there is I'm back on the whiteboard, aren't I? I don't need to show the whiteboard anymore. Okay, so there is a website you all can go to called dummyjson.com. And let me share this in Slack. Okay, so there's this there's this website that provides what's called a REST API, a JSON REST API, which is like the most common sort of API that people build for web apps to consume. And they just have like kind of some samples. So it's a good thing to kind of play around with and get familiar with. So you can go to their docs once you go to that site, and this is documentation on an API. So like what things you can ask for and what sort of things are supported. So we just talked about the main different HTTP methods that we'll be using. Get, post, put, delete. So those are, the ways that those verbs are for when you're trying dictate like what you're trying to do. But how do you know like what you're trying to do it to? So what are you deleting or what are you creating is all dictated by the URL. So just like in our browser, we learned about the URL and like that the URL dictates some sort of location in our app. So, when we go to, so when we go to pitchfork.com, we're on the root URL. And then, so like pitchfork.com / nothing after it, root URL. But if we go to news, then the URL changes to /news. And so the different, the application's rendering different information. And so we, and that can continue to sort of change. So if I like dig into something, then typically that's, pitchfork.com /news. And then in this case, since I clicked on a news item, it's sort of like in the ID of the item. And so it adds, in this case, it's like a text version of it so it's like not just like a nonsensical ID, but it's like a pretty long descriptive name for it. So that's like a specific item. And so the page knows, hey, like we want to display that specific item. So get that item and only show that on the page, right? So the URL is dictating the state of our web application and what we want to look at. That same exact pattern of the URL representing something is used for the backend as well for the API. So when we look at this REST API, I'll zoom in a little bit. You guys are familiar with Fetch, the web API for talking with an API. So the URL is here. So we've got HTTPS / and then the origin dummyjson.com. So that's this website. And then if we go to /products and we do a GET request, which is the default request type if you don't specify when you use Fetch. So we just specify the URL, it'll do GET, is a GET request to get products. So what do you want me to get? I want you to get products. So they have a bunch of dummy products that you can see. So we can open this in our browser if we want to and just see it. So I can go to that URL and you can see it's responding. This is a JSON REST API. And so what that means is it's going to respond with JSON, and the different things you can ask for are URL based. REST is like a specific way to use it's like REST is like the you learn REST to understand like, well, what URLs like for me to expose I'm like making an API, what should I make my URLs? REST is like the it's not like a scientific thing, but it's like the paradigm that you'll follow to come up with what URLs to use, because you decide what URLs you want to use. So if you're making a coffee shop and you want to expose on your API what products you have, well, you decide like /products /coffee items /inventory, like you decide what that URL should be. But like the art of deciding is REST. So a RESTful API is one that tries to organize the URLs in a particular way. And there's like articles I'll have you read about what that is. But you pretty much just make it up. You pretty much just decide what you want, because you're the one that's going to integrate with it. So as long as you know what it is, it's fine. So anyway, sorry, that was a bit of a ramble. So we're receiving JSON back from the API. And JSON is just like a format that we're very used to, that's very similar to like an object that's got like a bunch of different data in it. So you can see it's just like a bunch of text, though. It's kind of hard to read. So there's actually an app called Postman that you can install that will like let us more easily view the data that's coming back. It also allows us to do the other types of requests, because the only requests you can do in your browser is our GET requests. That's all. Like when you type in a URL in the browser search bar, it just does a GET request, but no matter what. So Postman, which you can install, allows you to do the other verbs. So I can take that same URL that I just went to, so dummyjson.com/products, and make a GET request, and then it will sort of like format the response for me. So you can see that's returning an object that has a key called products, and then that key has an array of objects, which are the products. And so it's just like a bunch of sample data. So iPhone 9 and a price, and then iPhone X and Samsung, and so just a bunch of random product data. But yeah, it responded with all of that. And we need to talk a little bit more about the different pieces of these requests. So the response here, the actual data that we want back is a part of the body. But there's another part of a request and a response besides the body of the request and response. Does anybody remember what that other piece is?
Header.
Yeah, so there's headers, and you can see that there's like this tab for that here. So we can see some of the headers that were in here. So these are the headers of the response. The headers of the request are up here. So you can see here are the headers for the request. And you are normally not going to be setting these yourself, except for the content type. That's usually the only thing that you are going to need to set. You can see this is has some other things like the user agent. So it's just like, hey, I'm Postman. And like often, like when you're making a request from your browser, it will tell the server like, hey, I'm Chrome or I'm Firefox or whatever. But that's not like a necessary thing to do. And you can see it's saying, I'll accept anything. So anything you want to give me back, that's cool. And so this thing responds with, okay, well, it responds with the body, and then in the headers, it will tell it that, hey, the content type is JSON, just so you know. So it's telling that here. And then the other really important thing is the status code. So whenever you're making a request, you need to know, did it work or did it fail, and why did it fail? And so it worked, and since it worked, we get status 200 okay. But there's a bunch of other statuses that we could get. So if we like ask for something that doesn't exist, like product, it's going to give us 404 not found. So you can see, hey, that is not a URL that our REST API defined. So we don't know what you're asking for. And so we get 404 not found. If something horrible happens, and their server like crashes when I make my request, then we would get a 500 internal server error. And then the other one you'll typically see is like a 401, which means like you are not allowed to do that. So eventually, actually more in the capstone, we'll get to like logging in and like having a user that you're associated with. And the way that we do that, like identify ourselves, is through the headers as well. So you'll add like a token in your header that's like, here's me. Because you like, so what happens is when you log in, you'll type in like your email and your password. And then if you correctly give that information to it, it will respond with a token that is for you only. And then you add that token to every request that you make after that in the header. And so the token is like this unique string identifier. So that also goes in the headers. And then whenever you make a request, it can look at that token and see, oh, it's this person. And so like, I can show them this or I can't. And so 401 would be like, hey, you don't have a token, so you can't do this, or hey, you don't have the right role to do this or something. Like only an admin can do this and you're just a normal member or something like that. So that's about what you need to know for the headers and the status codes. Those are kind of the main ones you'll use, is 200 and 404 and non-authorized, which is 401. Okay, so if we want to do other things besides get, so I can go back and correctly type in this URL. So I am asking for products and I'm getting status 200 okay. If we wanted to do something else, we have this drop down here and it has all the other verbs that are allowed in HTTP. Now there's a lot, and I've never used most of these. I don't even know what unlink or purge is. The main ones are get and then post and then put and then delete. I've seen patch more and more lately, but it's not something you guys need to necessarily know. So if we want to create data, we switch our verb to post. And so if we look at the API docs for where we go. Sorry, I don't want to be. There we go. If we look at the API docs for products, you can see there's get all products, get a single product, which you can see is like products /1, which is like the ID for it. So this will only return the first product. So there's the different, URLs we can use with get, but then eventually you'll see there's add a product, update a product, delete a product. So we can go to add a product and see what that looks like. And you can see the way we do that is the URL is products /add. So they're, telling us that's the URL we should use to add a product. And then since we're adding something, our method needs to be post. So with fetch, we have to then add this second parameter here, which is like this configuration object, and say method is post. Since we're sending data, we need to tell them the format of the data. So we're saying, hey, the content type is JSON. And then we have to provide a body. So a GET request doesn't have a body. It's just a URL with GET. We don't have to send any data for a GET request. We just need the URL. But for a post request, we need a body because we need to give them the data that we want them to add. And so we send that as JSON. So there's this JSON stringify here. And then you can see they just pass titled is the only property that they're passing, but we could add other properties. So we would send this request and we would get the response back, and then we would see, hey, was the response 200? Then good, we successfully added that product. It's now in the database. And if I make another GET request to products, it should be there. Like it'll be in that return in that at that point. Now, this is like a dummy JSON API that anybody can use. And so it doesn't actually add anything to the database, but it will give you a successful response. So you can see that's actually what they say here. Hey, adding a new product will not add it into the server/database. It will just simulate that it worked. So we can do that if we want. So we can go back to our Postman. We can go to dummyjson.com/products/add, do a post request. And if I can send it now, but it's not going to work because I'm not sending a body, right? So if I go ahead, if I send this, actually it said 200, okay. Let's see what it responded with. Yeah, so I didn't give it any data, and so it's just responding with an ID. But we can go ahead and give it some data. So we can go, hey, we want to do a body. And then we're going to do JSON. And then I can put, title test. So now I've added a body and I can send that. And you can see in this case now title is added in the response for what was supposedly, added to the database. So if we wanted to update data, then we need to specify the ID of the thing we want to update. So with put, we're saying, hey, something already exists in the database and I need to update it. So an example of that would be like you have like a to-do list and you want to mark a to-do item as complete. So you would say, hey, here's the item I want to update and I want to change the status of it to complete. So the way we do that typically is in the URL, we need to pass the ID of the item we want to update. And in most databases, the database creates the ID for you. So if you add something to the database, it's going to auto-generate a unique ID for you that you would use throughout your application. In the case of this like dummy JSON API, they're just using like integers, but you'll typically see like a more like kind of funky kind of string that's got like a bunch of characters in it that's unique for IDs. So this is saying, hey, I want to update the first product, and our method for that is put, and we're still going to pass you JSON. And in this case, I want you to update the title. So keep everything else the same and just change the title to be this. So if we looked at like my example of the to-dos, which they have in this, you can see they have like a bunch of different data in here: products, carts, users, blog posts, images, and then you can see to-dos here. And so we can look at like updating a to-do, and you can see that's the example they use here is you're updating the first to-do and you're marking it as, in this case, not completed. So you're updating the status from complete to not complete, but all the other data is staying the same. So the name of the to-do and stuff like that wouldn't get changed. And then you can also delete a to-do. And for that, you don't need to pass any data to delete something. So the method is delete, and then you just specify which thing you want to delete. So all of these examples are using an existing API. But what we're going to be mainly learning in this class is, well, how do you write the thing that allows for this? But I kind of wanted to just go through this so you guys can see like how they're choosing to do the URLs, which is usually like the name of the kind of thing, and then and then potentially like an identifier that comes after it. Okay, any questions about this? Okay, good. So, you guys may or may not remember, but we have written a server before. Oh, you know what? Actually, I want to talk about databases real quick. Does anybody know a database? Like a type of database? Has anybody ever heard of one?
Like SQL?
Relation.
Yeah, so SQL, I didn't hear what the other person said.
Relation database, I think that's also SQL based. I don't know if that makes sense.
Sorry, you're a little muffled. Did you say relational?
Yes, that's correct.
Okay, yeah. So there's like a lot of different terms in databases. You'll hear relational databases, and you'll hear like SQL databases. I think at like the highest level, you'll hear people typically say, are you using a SQL database or a NoSQL database? So like there's like SQL type and then just not SQL type. So for a really long time, SQL was like the biggest type of database. And SQL is SQL is like people, it's an acronym, but people say SQL, and it stands for Structured Query Language. And you would typically ask for and get data from a database, a SQL database, by like writing a query, like a string text description of your query, and that the way those looked is like select what columns you want, like select type, comma, ID, comma, name, just like whatever columns are in the database from, and then the table name. So like products or posts or whatever you name the table. And then you have all these other options like where, and where is like a clause where you may like describe, like you would specify what you want. So like where ID is 1, or where the title is equal to this, or where the date is less than 5 days ago or greater than 5 days ago, or whatever. So there's the database supports like asking for information and filtering information in a bunch of ways, and then also updating information in a bunch of ways, and then adding information as well. So there's also like, create this thing. Now the way that it's storing that data is very much in sort of like a table format that's very similar to like a Excel table. You can think of it pretty similar. There's like columns and rows. And the way that you interact with it is through the SQL language. Now, we will not be using SQL in this class. So there was a big change when NoSQL came out, like, I don't know, like 10 years ago or something. I'm not sure when. What was the first NoSQL?
I have to do SQL, and I'm just not. That's not my vibe. I don't like
Yeah.
SQL.
Yeah.
Really? I love it.
Really? I didn't know there was a NoSQL database. I didn't know that this
So
was.
I guess it first came out in 1998. But it was still a relational database in that case, which relational means like you can make relations between tables. Like you would make like a user table, and then maybe you would make like a company table. And so there's like companies in the company table, but then like if you work for that company, then you might have like in the users table, you might have like company ID as a column, so that you can then say, here's the ID of the company I work for. And so that makes this relation between the user table and the company table. And then the relations are usually done by IDs. So the ID of the record in the database, you have this like link to it. So MongoDB is what we're going to be using in the class. And so you can look up MongoDB, yeah, so 2009. MongoDB was sort of like the first NoSQL database that got really popular, and it's really popular now. So a lot of people use MongoDB, and MongoDB is it stores essentially JSON. So like whenever we like get JSON from our API, when it gives us data in the JSON format, and we like send data in the JSON format, it essentially just sticks that in the database. So there's there's no difference between the data that you're interacting with in your server and in your client, and then ultimately what's in the database. So you can think of MongoDB as just like, hey, I've got some JSON and I want to store it. Then you can, with MongoDB, you can do that. And so it like really kind of simplified a lot of things. And so a lot of people use it that do web apps. Now SQL is still really popular as well. And there's like advantages and disadvantages to using MongoDB, just like there are advantages and disadvantages of using SQL. But it's a much lower learning curve typically for people to learn MongoDB first. And it's what I use at work. We use MongoDB. And the way that you query it and the way that you interact with it is through like it's basically like JavaScript. There's like a find method that you call, and then you like pass it an object that like can specify different conditions that you may want to use to filter things. And there's like a create method and a delete method. And so it's like, first, it's like easy to understand how the data is being stored and what the format is. And then it's also like not a big jump to figure out how to interact with it, because it feels like you're using JavaScript basically. So that's the database we'll use. And I just wanted to mention that real quick. So back to the server stuff. So we made a server, I think, in the first day of the Node class. And it was pretty similar to this. So here, let me zoom in a little bit. So here was pretty much, I think, the same code that we wrote. So this is a Node script, right? So we're back to writing JavaScript for Node because we're writing a server and that's going to run on a computer somewhere. So this is Node, and so we're importing that HTTP module from Node. And then everything else here is just setup we needed to do to start writing a server. So we've got the host name, which is our local host, just for like this computer, like the server's gonna just listen on the IP address of this machine. And then port 5000, so that can be kind of anything that we want, 3000, 5000, 7000, 6000, kind of whatever you want. And then we use that HTTP method to create a server, and then it gives us the request and the response as a callback. The request is all the detail on what the request was, and then the response is something that we can use to like create the response we want to give, and then ultimately send that response. So this is just saying, hey, any request, no matter where it's coming from, and what the URL is or whatever, just respond with 200 with content type, just plain text, and then just say hello world to them in text. So that's like our configuration that's like all the logic of our server is just like, no matter what, just send this back. And then we then tell the server to start running and listening. And so that, remember, that just like keeps running forever. So we can run this server. Does anybody remember how I run this file?
npm start.
So yeah, that is often how we'll be doing it when we have like our like framework installed, and we're gonna use so just like how we're using React as a framework to do our front end development, we are going to use a framework to do our back end development. But I don't have that installed in this case. All I have is this JavaScript file. So how do I just like run a JavaScript file?
Larry said node server.js.
Yes, exactly. So node server.js. And so now our server is running. And we console logged that it's running at this location, but now you can see like I can't do anything with the terminal here anymore because my server is like running still. So there's a process happening in this terminal. And so it's not waiting for commands anymore. It's like running node, and node is staying open. It's continuing to run because it's listening for traffic. So we can now go to this URL, and I can go to this URL in Postman, just like I did the example we were looking at just a second ago. So I can make a GET request to this. So I can do HTTP : / we're not listening on HTTPS, we're just listening on HTTP. And then I can do, 127.0.0.1. And it's port 5000, so I need to specify that. And then I can send this request, and you can see, okay, so like the request worked, and it responded with a body hello world, and the status. Can you guys see this, by the way? Okay, status 200 okay. And then if we look at the headers, the content type is the main one that we set, and it's text plain. So it's just telling whoever's getting the response back that, hey, this is just plain text. It's not JSON. And then here's that body. Now I can put /products and make this a post request and send this. And what do you guys think will happen?
Not found.
So that's a good guess.
Wow.
Definitely a good guess. In this case, it's just 200 okay. And I can do a delete or a put or anything. And the reason why is because I didn't write any code to tell the thing that was talking to me that it's not found. The only code I wrote doesn't care at all about the request. Notice the request is whenever you don't use a variable, and it'll be like a slightly lower opacity. I'm not looking at the request at all. I don't care about it. And I always respond with the same thing. So the whole, everything we're going to be learning about, how to write a REST API is simply what is the request? And based off that request, what's the URL? What's the method? What's method is it? And then based off that, do something different. So the URL is simply this thing that's you're using to figure out what you want to do. And you have to write all that. So if the request, so we can do it. So we can say, if the request dot, I need to think about where the path is. Okay, so method, look at, yeah. So if request method equals get, then we can do this. Else if the request method is post, then we can do post. So we can look at the method that they're using and decide, and then we can do else. So every other situation, just did, we can, in this case, we can do 404. So now we're adding logic to our server. So we're saying, hey, if they do a GET request, respond with hello world. If they do a post request, respond with hello world post. If they do any other request method type, respond with 404. So we can test that out. I have to kill this server and start it over since I changed it. So I'm doing that now. And then we go back here, we can do our GET request. And we get hello world. We can do our post request, hello world post, and then we can do a different type patch. And in that case, we get status 404 not found, and then body not found. So all of that code was in sort of one spot. And we're also not looking at what the URL is. So we can also like add logic to say, is the URL products? Well, then do this. And is the URL something else? Then do this. We could write all that just, you know, with if statements and like checking the URL and checking the method like this. But that's such a common thing that there's frameworks for it that make it easier. So like, just like setting all this stuff up in a clean way. There's a framework called Express that makes it really easy to do that. So that's the framework we'll be using. And it is essentially just like, you know, depending on the URL and depending on the method, like do different things. So that's what we're learning. And then we'll, you know, whenever you're doing different things, then, you know, you'll potentially talk with the database and get certain data based off the URL. Or you may get something from the database and then send an email and then update the database that the email was successful and then respond. So there's a bunch of different branching logic you'll do depending on what is happening. So yeah, all right, we're out of time. Hopefully that was just a nice higher level overview of everything, and we'll start getting our hands more dirty on Saturday. And I'll send homework tomorrow morning.
All right, sounds good.
All right, thanks everyone. Great to see you all again.
See you again on Saturday.
Good
Thank
to see ya.
you.
See ya.
Yep.